for there are many senior colleagues in my faculty, indeed in our great university, who are yet to have this opportunity. Worse still, many our professors have retired without being able to present inaugural lectures. Again, I'm highly indebted to the merciful God. An inaugural lecture is meant to showcase major research breakthroughs of the lecturer. It is supposed to be understood to a great extent, even by those who are not in the field of the lecturer. This is because an Iwuye ceremony is supposed to entertain and satisfy all the invitees. I will try as much as possible to achieve this goal, though not at the detriment of technical details. This is the 7th PIL coming from my great department since its inception some 54 years ago. While Professor A.J. Raymond was the foundation head of the department, Professor Moshabalaje Oyawoye was the first African professor of geology. Although I am the 5th professor of engineering geology in Nigeria, today's lecture is the second to be presented in engineering geology in the country. The first, entitled Environmental Degradation and Human Welfare, Emerging Challenges for Geologists, was presented in 1998 by Professor Enuvie Akopoje of the University of Port Harcourt. Today, Nigeria can boast of 8 full professors of engineering geology, arguably one of the highest in any country in the world. I chose the topic engineering geology, the big heart for structures and the environment, for many reasons. First, it is meant to enable more Nigerians appreciate the relevance of engineering geology in long-time stability of structures such as buildings, roads, bridges, dams, and tunnels. Second, to present most of my findings on geological and engineering properties of rocks and soils in southern Nigeria. Lastly, to provide solutions to incessant failure of our structures. Engineering geology. Geology can be defined as the science of the earth. Geology studies the composition and structure of the earth and the processes that modify them. Geology can be broadly grouped into basic and applied aspects. Courses in basic geology are often taken at early stages of the training, for their knowledge is invaluable in applied geological disciplines. Important basic geological disciplines are physical geology, petrology, which is the scientific study of rocks, mineralogy, structural geology, paleontology, and photogeology. Courses in applied geology are historical geology, applied geochemistry, economic geology, applied geophysics, and stratigraphy. Others include petroleum geology, hydrogeology, engineering geology, environmental geology, agricultural geology, and medical geology. Students of geology are expected to have sound knowledge of basic sciences such as biology, chemistry, mathematics, and physical geography. Engineering geology was founded as a discipline by Professor Karl Tazagi, who lived between 1883 and 1963. He established the discipline in 1938. He was then at the famous Massachusetts Institute of Technology, United States of America. Tazagi was a structural engineer who specialized in the design of dams. He however discovered that most of the dams he designed with members of his team did not last long before they failed. It then dawned on him that it was necessary to understand the environment, especially the geological environment where a dam was to be built. He had to work with some geologists who in turn seized the opportunity to learn some aspects of civil engineering. The civil engineers are, of course, learning some aspect of geology, which is geology for engineers. Tazagi, who had earlier established soil mechanics as a discipline, thus doubles as both the father of soil mechanics and the father of engineering geology. Geotechnical engineers worldwide hold Tazagi Memorial Lectures on an annual basis. Engineering geology can be defined as the application of geological sciences to the solution of civil engineering problems. In terms of scope, engineering geology is geology for engineers combined with geotechnical engineering, which is an important branch of civil engineering. Engineering geologists worldwide work hand in hand, not only with civil engineers, but also with agricultural, environmental, mining, and petroleum engineers. This is in agreement with the assertion of Geology 2002 that the practice of geology has likewise maintained a valuable relationship with some applied disciplines, including mining engineering, petroleum engineering, metallurgy, mineral processing, and materials. As practiced worldwide today, engineering geology can be defined as the application of geological sciences to the solution of engineering problems. Engineering geology forms a link between geology and civil/mining engineering. A person with geology background wishes to become an engineering geologist must be well-graded in geotechnical engineering at postgraduate level, while anybody with civil or mining engineering background should master geology for engineers. Courses that constitute geology for engineers include petrology, mineralogy, applied geochemistry, applied geophysics, photogeology and remote sensing, social geology, hydrogeology, and environmental geology. Engineering geology in Nigeria. Engineering geology became popular as a discipline in higher institutions in Nigeria during the late 70s. The then Dr. Shiama Loma, who bagged a doctorate degree in engineering geology from the Department of Civil Engineering of the famous University of Leeds in 1977, was arguably the first Nigeria to attain the feat. He later joined the Department of Geology of the then University of Ife. Celestine Okogwe, S.C. Teme, and Enuvia Kokoje also obtained doctorate degrees in the field of geology from outside Nigeria. The then University of Ife produced doctorate degree holders in person of Olufemi Odugusawo and Ajibola Meshida in 1984 and 1985, respectively. They have all made their marks as distinguished professors of engineering geology. Professor Shema Lama, for instance, has been the Director General of the Geological Survey Agency of Nigeria, NGSA, for almost 10 years, after spending about 15 years at the Commonwealth Secretariat, London. Professor Ajibola Meshida won the Liquefied Natural Gas Prize as the best Nigerian scientist in the year 2008. I need to say here that Professor Meshida supervised my PhD thesis between 1987 and 1991 at University at OAU. He discovered a flux, otherwise called stabilizer, that has the capacity to strongly indurate and hence protect any lateritic soil from being penetrated and weakened by water. The stabilizer, which he called lateralite, if appropriately deployed, will reduce, if not prevent, incessant road failure in the tropics. My voyage into the field of engineering geology. Although I was very good in literature while in secondary school, a situation that earned me the appellation Okara, after the famous Ijaw poet Gabriel Okara, I made up my mind to be a scientist. I was lucky to be taught physics, biology, and chemistry by crops of good science teachers. They were the late Mr. A. Ojesami, Mr. Shola Oyetola, now a venerable, and Mr. Kola Junaid, now a PhD holder, respectively. I was admitted to the Faculty of Science in 1976 with my knowledge that geology was very lucrative. For one could work in a petroleum company, I opted for the course. I developed an abiding affection for chemistry even as a geology student, a situation that made me take chemistry courses up to the 300 level. While in 400 level, however, the efforts of the then Dr. Shiana Lama, Mr. E. Meshida, and Dr. Adegoke Anthony, a geotechnical engineer, aroused my interest in engineering geology. I eventually wrote my BSc project in engineering geology. I was employed as a geologist by Sofon Limited immediately, just about a week after my national service in 1981. My first job as a geologist working with civil engineers was to take part in the subsoil investigation for the proposed Lower Usman Dam in the Federal Capital Territory. The dam is still in operation up to now. I left the company after 15 months for a water drilling company. It was thus not difficult for me to take a combined master's degree program in engineering geology and hydrogeology at the then University of Ife between 1983 and 1986. In 1987, I enrolled for a Doctor of Philosophy degree program in engineering geology at OAU. To the glory of God, I defended my thesis entitled Highway Geotechnical Properties of Lateralized Residual Soils in the Ajebo Ishara transition zone of southwestern Nigeria after 50 months. As an associate lecturer in the Department of Civil Engineering, OAU, between 1990 and 1997, I had close interaction with both lecturers and students. The free geotechnical engineering courses at undergraduate levels were taught by me. I also supervised many final year projects in the department. One of the first set of students I taught, geotechnics, Engineer Kefle Soye, was Commissioner for Works in Ondo State during the military regime. Engineer Dr. G.O Adeyemi, and also a professor of civil engineering, was the immediate past dean of engineering at the University of Technology. I'm very proud of them and many others like my 5 PhD graduates in 3 different fields of geology and many first and second degree holders in geology and civil engineering. I have over the years been spreading the gospel of engineering geology to virtually all universities where geology is taught in southwestern Nigeria. I have no regret whatsoever being an engineering geologist, for I feel very much at home with both geoscientists and civil engineers. My contribution in the field of engineering geology. My main areas of research interest are: 1, influence of pyrogenic, otherwise called soil-forming factors on engineering properties of soils; 2, soil stabilization with special emphasis on mechanical stabilization and chemical stabilization; 3, engineering geological studies of crystalline basement complex rocks; 4, groundwater exploration. Other areas of interest are foundation investigation for structures with emphasis on highway geotechnics, foundation investigation for buildings, and subsoil investigation for dams. Environmental geology is another area of interest, and I specialize in 3 aspects of that: environmental engineering geology, environmental hydrogeology, and environmental petroleum geology. I have confirmed that factors such as parent rock, position in soil profile, and topography have tremendous influence on the mineralogical, geochemical, and geotechnical properties of soils. Adeyemi, 1994, observed that soils develop over 3 different rocks in Ishara and Ajibor areas had widely different mineralogical and geotechnical properties. And as you can see from Table 2, most of the geotechnical properties are strongly affected by parent rock factor. Topographic sites. Adeyemi 2003 found higher amounts of kaolinite and ferric oxide in soil samples taken from gentle slope than in those from flat terrains. And based upon all these findings, together with the fact that geotechnical properties of these rocks are better, we have recommended that it's better to win material for construction from gentle slopes instead of from flat sites. Group 2, soil stabilization. But the question of soil properties is as old as man. The Bible records that the Israelites were made to stabilize soils with grass before being used for brick production. So the same day, Pharaoh commanded the taskmasters of the people and their officers, saying, "You shall no longer give the people straw to make brick, as before. Let them go and gather straw for themselves." Exodus 5, 6-7. The 2 main types of soil stabilization are mechanical and chemical. The commonest form of mechanical soil stabilization is compaction. Virtually all types of soil stabilization involve compaction, which can be defined as densification by addition of dynamic load. Mechanical stabilization. This refers to the modification of properties of a soil, either in the laboratory or outside, through purely physical means. The 2 main forms of mechanical stabilizations are: 1, compaction at an appropriate level, and 2, mixing of certain percentage of a good soil, the soil to be stabilized. Compaction at an appropriate level. When a soil is compacted at an appropriate level, its strength will increase, while both its compressibility and permeability will reduce. Such a soil can then be a good foundation material for structures or good soil for a landfill. Mr. Vice Chancellor, sir, since engineering geological knowledge can help in attaining this feat, engineering geology can be regarded as the big heart for structures and the environment. Some tropical geotechnical engineers, DeGraff Johnson and Batia 1970, recommended the West African level for compaction of lateritic soils. And this is based on their conviction that the modified American Association of State Highways and Transportation Officials, acronym ASTO, level has the tendency to overcompact and hence cause excessive degradation of grains of lateritic soils. However, I have established that most lateritic soils in southwestern Nigeria, indeed in southern Nigeria, are in fact not overcompacted at the modified ASTO level, as many of them have been found to be mechanically stable at the level. Adeyemi 2003 did not record any statistical increase in the amount of fines when samples of pegmatite-derived soil, which is the most voluminous and extensive soil in Nigeria, near Abeokuta, taken from Ajebo, were compacted at both the West African and modified ASTO levels. And this can be confirmed from our table 8, where the percentage increase in amount of fines are generally low than 20%. Similar trends have been observed in many lateritic soils from southern Nigeria by employing mechanical stabilization to determine mechanical stability of soil samples. A soil sample must thus be subjected to as many levels as possible to determine the ideal level for its compaction. Such a level must not result in excessive breakdown of particles of the soil, but should cause significant increase in its strength and appreciable reduction in its compressibility and permeability. Mixing certain percentage of a good soil with the soil being stabilized. This is another form of mechanical stabilization. This can be executed by mixing certain percentage of a good soil, most of the time by weight, to the one with the one whose properties need to be improved, followed by compaction and at an appropriate level. We have employed termite work soils from many parts of southwestern Nigeria to stabilize lateritic soils. Mr. Vice Chancellor, sir, it will interest you to know that some well-organized social insects, termites, of the genus Macrothermes stabilize soils. They construct edifices called termitaria, inside which is the well-fortified palace that houses their queen. The construction of termites mold by workers, which are well protected by soldiers, involve excavation and shifting of the soils to the surface. The soils, mostly of the clay and silt fraction, are then mixed with the saliva and fecal material from the termites and at times some other debris to form a tough material. And we have pictures of the one taken from Ijagunai Debode and the one taken from Akingbile Amaniya. Adeyemi and Salami 2004 confirmed statistically significant improvement in geological properties of termite work soils from Agoiwoye over those of nearby soils taken from identical depths. Oyedina et al. 2008, for instance, recorded substantial improvement in engineering properties such as plasticity, specific gravity, and CBR of termite work soil over those of lateritic soils from Akungba Akoko. This project, written by an academic grandson and supervised by an academic son of mine, won the best degree project in geology in Nigeria in the year 2007 under the auspices of the NMGS ExxonMobil Award. In view of the limited volume of termite work soils in Nigeria, we have been using them as stabilizer for lateritic soils. Ogunjobi 2006 noticed appreciable improvement in engineering properties such as CBR and confined compressive strength when samples of amphibolite derived soil from Ifewara Road, Ile-Ife, were stabilized with 25% by volume of termite work soils. Our most recent work on mechanical stabilization using termite work soils at the 2013 showed remarkable improvement in both CBR and confined compressive strength of samples of pegmatite-derived soils from Otun Agbakin, Namani, Ibadan. We confirmed that addition of 10% by volume of termite stabilized soils to samples of lateritic soils subjected to modified ASTO level of compaction can produce soils of adequate strength for high waste of base. And we have our table 10 demonstrating that. Soil stabilization of some residual lateritic soils with lateritic soils of better engineering geological properties. What we are saying here is that If you have two soils, you can use one to improve the property of the other. 40% by volume of authentic soils was adjudged reasonable for effective stabilization of Ara-Ijero clay, allowed about 2009 MSCTs that I supervised. The peak strength that we noticed, almost 2,500 kilopascal of fire sample, is high enough for building construction. We noticed similar trend with clay from Ishan-Ekiti, Amangele 2009. We have all these on tables 11 and 12. We have also stabilized pegmatite nitrogen soil with schisto-quartzite soils from Okemesi area, and we have noticed significant increase in the properties. Chemical stabilization. We have stabilized athletic soil with cement, lime, and mixture of both using percentage by weight, which is the normal, is the trend throughout the world. And we have noticed that 10% by weight of cement was found to be adequate. Adeyemi et al. 2003 stabilized sample of granite nitrate soils using 0, 2, 4, 6, and 10% by weight of cement respectively. And we noticed significant improvement in properties. But what we have noticed with chemical stabilization is that mechanical stabilization is more effective than chemical stabilization. We have this on our various tables up to table 16. I need to say here that cement stabilized and cured bricks are currently being utilized for building and fence construction in parts of southwestern Nigeria. In fact, the Bukat area in Uni Osun, all the buildings are constructed with cement stabilized laterite soils. We also have fences that have been constructed with cement stabilized soils. And this will reduce the cost of our building drastically. Engineering geological studies of crystalline basement complex rocks. About 50% of Nigeria's land surface is underlain by hard rocks, most of which constitute the Precambrian basement complex, which geologists believe are over 500 million years old. These rocks are similar but not identical geologically and geotechnically. Unfortunately, the rocks are seldom tested prior to their being used for construction purpose. Besides, they are quarried without regard for the environment. Illusory. We have established that samples of banded gneiss from 3 quarry sites around Ibadan have similar mineralogical and geotechnical properties and are good for construction. Adeyemi et al. 2008. Samples of 6 different rocks from southwestern Nigeria were found to exhibit widely different geotechnical properties. We have been able to establish mathematical models which we can use to determine basic properties from properties that are very cheap and fast to determine. Groundwater exploration. Groundwater is an important consideration in engineering geological investigation. The depth to water table and groundwater chemistry often form part of the geotechnical report for any proposed structure. However, while hydrogeologists are interested mainly in the constructive aspect of groundwater, engineering geologists and foundation engineers are more concerned with its destructive aspects. Site drainage, environmental impact assessment and evaluation of any location for waste disposal require knowledge of hydraulic properties such as permeability of